Welcome to Microsoft Build 2017. My name is Parshuram and I'm a Principal Program Manager on the Visual Studio Mobile Center team. In this team, we build cross-platform applications using JavaScript. I'm also a committer in the Apache Cordova project, and more recently, I've been working on building developer tools for React and ReactNative applications. In this talk, I'm going to be talking to you about building cross-platform applications using React and ReactNative. When I say cross-platform, I'm talking about building applications using applications for iOS, for Android, Windows, and why just stop there? I mean, it's all building with React, right? And given that you're using React for building applications, you're typically going to be using JavaScript, TypeScript, or ES6. And as a result, when we say building cross-platform applications, we can also build it for the web. The way the React application is structured is something like this. So a typical React component is structured in terms of views and text. These are typically components that you think about when you compose your user interface. Each of these components are then transferred into whatever the native interpretation of that component is going to be. For example, in case of iOS, it's going to be a UI text view. In case of Android, it's going to be the typical Android widget. In case of Windows, it's going to be a text box. And in case of the web, it's going to be div or span. And this is one of the biggest advantages of using React to define your user interface. When you're defining your user interface like this, you are effectively just declaring what the user interface looks like, and you let React interpret it and display native interface for which platform it is running on. All of this is written in JavaScript, and as a result, all of this also runs using a JavaScript engine. Now, if you're using React Native on iOS, it runs on what is called JavaScript Core or JSC. On Android, it also runs JSC, which is packaged. If you're trying to run this on Windows, you have the powerful Chakra Core engine, which interprets and runs all of this JavaScript. And of course, when it's running on the web, it's the JavaScript engine that your web browser contains. Typically, things like V8 for Chrome, SpiderMonkey for Firefox, or in case of Edge, it's going to be Chakra Core. All of the JavaScript that's interpreted is actually converted to native user interfaces, and that's one of the reasons why React Native looks and feels so native and so like an application that's written for a particular platform. Now, if you were to take your application and compare it, effectively you are pretty much packaging your JavaScript engine and your native code into one package. That's what gets distributed over to your mobile phones. Now, effectively, all of your JavaScript that's written on your desktop is packaged or bundled. A typical bundler is something like Webpack or Gulp or Grunt. So the packager basically picks up all of your source code, bundles them together, and sends them over to your JavaScript engine. And once this JavaScript engine interprets it, it starts sending commands over to the native layer, telling it to draw a button or a text box or any other UI component. Now, this is how React Native typically works. One good way to compare it is how does it compare against technologies like, say, Apache Cordova or PhoneGap. React Native is actually pretty different from Cordova or PhoneGap in a sense that a typical React Native application uses native user interface elements. Cordova, on the other hand, has web views. Now, a web view is very much like a web browser without the address bar or any of the Chrome around the web page. So in case of a Cordova application, the application uses HTML elements to make it look like a native application, but it's not really a native application. React Native, in a way, is also very, very similar to what a Xamarin application might look like. The only difference being, in case of Xamarin, all of the logic, all of the business logic and code is written in C#, and it's compiled over either to an intermediate language or an assembly kind of a thing that then interacts with the native UI. In a way, Xamarin and React Native are much closer to each other because both of them have a different language where your logic is written in, and all of your native user controls are in the native language of the platform. Now, here's a small table that compares and contrasts these three applications. I'm not going to go through all these individual rows of the table, but it suffices to say that while your authoring experience for all the three might be a little bit different, eventually all of these give you output as a web, a Windows, an iOS, or an Android application. As you start getting into the final stages where you want to deploy the application or distribute the application, it's very, very similar in all of these three platforms. Given that the talk was about building cross-platform applications and not talking about it, let's actually jump in and see how we can build one. For the sake of this demo, I'm going to be using React Native for Windows because we wanted to build a Windows application in addition to iOS and Android. I'm going to be using this platform called React XP, which is a cross-platform library created by the folks at Skype that lets you share code between iOS, Android, Windows and the web. I'm also going to be using VS Code as my editor because it has some pretty amazing IntelliSense and debugging capabilities. And finally, I'm going to use Visual Studio Mobile Center to ensure that I have an end-to-end continuous integration setup. And I'm going to attempt to do all of that in the next 15-20 minutes. So let's head over to the demo. The first thing I'm going to do is I'm going to go ahead and create a new React Native application. Let me get inside the React Native application, and let me go ahead. If you look at the React Native application, you see two folders, one for iOS and the other for Android. Given that I want to share my business logic across iOS and Android, I'm going to be just creating a single source code folder and have a single component inside it called app.js. This app.js is going to be referred to by index.android.js and index.ios.js. So the app.js is basically the starting or the first component in my React application. Once I have that set up, let me go ahead and start creating a Windows version for it. React Native today by default supports iOS and Android only. If you have to create a Windows application, the quickest way to get started would be to use the RNPM plugin for Windows. I just installed that, and I'm going to go ahead and call the command React Native for Windows. Now calling React Native Windows creates a folder called Windows at the same level as iOS and Android, and this basically bootstraps my Windows project. I also have the starting point for Windows called index.windows.js, and I'm going to do the same thing that I did for the starting points of Android and iOS. Basically make that file point over to my app.js. The next thing I'm going to do is, because I also want to build it for the web, I'm going to go ahead and install this library called React XP. I'm going to write all of my code in ES6, so I'm going to also install Babel. Now there is the Android folder, the iOS folder, the Windows folder, and let me create a sibling for the web called just the web. Here I'm going to add two files, an index.html and a webpack config. These are just container files that will hold my web project. As you can see, the starting for my web project is going to be obviously called index.web.js, and once I have index.web.js, I'm just going to create that and make that the starting point for my web project. So the pattern, as you can see here, is I have 4 starting files, one for each platform. However, my main source code is still in the source folder and it's still app.js. And as I continue developing, I have to just worry about changing code in app.js once all of this is set up. So my webpack config is set up such that it compiles my ES6 files and runs the index.html, and that's all I have to do. Now let me go in and start editing my app.js. Rather than importing all my components from React Native, I'm going to now start picking them up from React XP. The reason I want to do this is whenever I say I'm going to use a view or a text from React XP, the platform basically takes care of rendering the version that is relevant to a platform. For example, when rendering to the web, the view is just going to become a span tag or a div tag. And when I'm trying to render it to the iOS platform, it's going to become a UI text view. The programming pattern is very, very similar, so you don't have to change a lot of things. In fact, one of the other things you notice here is the styles are also very similar, regardless of whether I'm writing a web application or an application for the mobile phone. So here my application is ready, and the application basically calls a RESTful API, fetches something from the RESTful API and displays the result. It's nothing complicated, and let me run my webpack to show you what the application really looks like. So my webpack application is ready, and let me go ahead and open up my index.html in Chrome. So that's my application, and there's a button called new joke. As I click on the joke, it just keeps loading a new joke every single time. The interesting thing here is I can use the exact same code and run the exact same thing on iOS device or an Android device. All of my logic, application logic, stays in my app.js file. Now I'm going to go ahead and start what is called a packager. Now this packager is very, very similar to the webpack config file. In fact, it's pretty much like webpack, just that it saves all of the contents in memory. So I'm going to start up the webpack packager, and inside Visual Studio Code, I'm going to say run iOS app. This starts up the app, and as you can see, the app is exactly the same. Now again, this is not a web page, this is actually an iOS app, and all the controls that you see are really native controls. In fact, what I can also do is right from within VS Code, I can even start debugging this application as if it was a website. So I have the extension called ReactNative Tools installed, and what I can do is once I enable debugging, I can start setting things like breakpoints and watches and typical things that I do with an IDE, and I will be able to use VS Code to debug my iOS application. And all of this, because it's all JavaScript, I can pretty much play around and do all the things that I'm typically used to when I'm trying to debug JavaScript. So that's the local variables, the call stacks, looking at watches, trying to put breakpoints in the application, etc. This is one of the advantages of using React Native. The debugging experience is very similar to what you would do if you were to write this as a web control. In fact, if you were to install the Chrome VS Code debugger extension, the debugging experience is going to be very, very similar, including the breakpoints, call stacks, and watches. Let's quickly look at how this looks in Android. So as far as an Android application is concerned, I'm going to bring up my Android emulator. I'm going to do the exact same thing where I start up or build my Android application from within VS Code, and it starts fetching the bundle. Once this Webpack-ish bundle is fetched, the application that looks is exactly the same. In fact, if you look at the styling, I just had to define the styling once, and I'm able to run it across all these devices. Interestingly, Windows is also pretty much similar. Because I'm running on a Mac, I'm going to open up Parallels, and I'm going to start up my Windows instance here, and I'm going to basically run the exact same thing. One of the other things to note here is, though I'm trying to share as much code as possible, React Native also lets you pick and choose platform specific things when you need them. For example, if you need a button that needs to look in a specific way in iOS or Android, you can actually do that with React Native. So here's my Windows application. It was on my Parallels share, so I'm copying it over to my local drive, and once I've opened it and copied it over to my local drive, I'm going to open it in VS Code and do the exact same thing. Given that VS Code runs both on iOS and both on Windows and on a Mac machine, the debugging and the development experience is pretty much the same thing. So on the Windows machine, just like I did on the Mac, I'm going to start up my packager and deploy my application. And here it is, the Windows application with the exact same source code. In fact, it looks pretty much similar to what it was looking either on the web or on the iOS or the Android device. Now that was all about like trying to debug and develop your applications across all the 4 platforms, but authoring your application is just one step. Let's actually go ahead and set up an end-to-end continuous integration story. The reason why we should be doing this is because once you have a CI story where you have builds, tests and analytics and crashes and everything integrated, you can forget about the hard part and just concentrate on your business logic. So here, let me push my source code over to GitHub and then go over to Mobile Center at mobile.azure.com. I can log in using GitHub, and I'm going to create 2 new applications, one for iOS and one for Android. At this point of time, we are actually working on adding support for React Native Windows also, but till that is done, let's just go ahead and create one app for iOS and the other app for Android. One of the other features that Mobile Center provides is it lets you play around with crash reporting and gives you great analytics. So I'm going to install the SDKs for both of them, and currently these SDKs are supported for iOS and Android. And once I do that, I'm going to create my Android application and inject all of this into my React Native application. So I'm going to say React Native link, and it's going to ask me for my app secrets, which I'm going to enter, and it's going to set up this whole thing. Now the interesting thing here is, as a JavaScript developer, I don't have to worry about Objective-C code, or I don't have to worry about trying to get into a different IDE. I can pretty much run this using Node commands and in Visual Studio Code. So that was all the changes that were added because I added a couple of SDKs. Let me go ahead and commit them and push them over to GitHub. So there it is on GitHub, and let's now go ahead and set up build. Setting up build is pretty simple. Because I had already connected to a GitHub repository, I can click on the GitHub branch and the repository that I want to set up. Mobile Center also lets you do code signing very, very easily and quickly. As far as iOS is concerned, the only quirk is when I created the project, I have to set what my code signing entity is. And that's probably the only time I'm really required to open Xcode. But here, let me just open Xcode and say that here is my provisioning profile and here's what I need to do for signing. And once I'm done with this, my signing is pretty much set up. Now I'm going to go ahead and commit this change and then continue setting up my build process. For my build, I'm going to say, I'm going to go back to my build process, and if you look at Mobile Center, it has automatically picked up the last change. So I'm going to say I want to sign my builds, and I'm going to pick the provisioning profile and the certificate that I originally selected in Xcode, and I'm also going to say whenever the build is complete, just send me over a copy so that I can play around with it and test it. This kind of beta distribution is actually pretty useful. Imagine a world where every single time you make a code commit, you actually have the entire app built and sent over to your customers or to your clients. That's actually a pretty good way to ensure that your development process is agile and you get feedback as and when you need. Now here I'm going to go ahead and set up the Android application in a similar fashion. The good thing about Android is I don't have to open Android Studio. I can use the command line to generate a key store, and I can just type in all of that information, and my Android setup is also done. So here I've just gone ahead and said finish setup. Now while the iOS app is building, I can go into my build menu and look at what it's doing. And while it's building, let me open up the device I have in my hand and wait for me to get an email that says the build is complete. Oh, looks like the build is complete right there. So I'm going to go back to my device and check my email. The email says both my iOS and Android builds are complete. And because this is an iPhone, I'm going to go ahead and install the app on my iPhone. Now anyone who was in the collaborators group would have gotten this email, so you should be able to distribute it to as many people as you want. So I went ahead and clicked on install, and that's my app ready. Now if I open up the app, this was actually the app built on the cloud by Mobile Center and distributed to your testers. Now because I've done all of this, let me also start adding a little bit more code. I don't have to think about building or testing anymore, so let me just start adding some code for tracking user behavior. Maybe the first thing I want to track is how many times have people clicked on the fact that they want a new joke. So I'm going to go ahead and track events there. I'm also going to go ahead and say, hey, whenever the button is pressed, go send this event. So I'm going to use the handle button press method and start sending events as soon as the button is pressed. So there it is. The other thing I want to do is, given that all of this is just JavaScript code, there is no real reason for me to need to build my native code every single time. I mean, I don't have to build my Objective-C or my Java project every single time, right? As a result, I'm going to actually use this service by Microsoft called Code Push. Code Push is a service that lets you instantly update your app without having to go through the App Store. So it's great. It's a great way to ensure that your bug fixes reach your customers as soon as possible. So I just installed Code Push, and what I'm going to do here is every time the app starts up, I'm going to check and see if there's a new Code Push update or not. So that's what I'm doing, where I say codepush.sync, and I'm going to say, hey, if there's a new update, just tell me, and then the user will be able to install it. So those are the changes. Let me go ahead and link Code Push first to ensure that all of my native changes are added to my native projects. This way I don't have to actually go manually do any of this work. And once I'm done, I'm going to commit this code and push it over to the cloud. Another thing to notice here is, as I was making these changes, and as soon as I pushed through the cloud, the build is going to start working. And that's because that's how I configured my continuous integration, right? And this is one of the advantages of setting up a CI system right from the beginning. Once you have it set up, you don't have to worry about it. So once this build is complete, what I can go ahead and do is install it pretty much like what I did the last time. So I got an email that said there was a new build available. I went ahead and clicked on it, and here's my application with analytics. If I click on new joke, looks like there's an error. Wow, that shouldn't have happened. This is embarrassing. But guess what? I'm glad we actually added crash reporting, because though that error happened, we have crash reporting and we are able to see exactly where the crash happened. Now that was line number 15, and that's where the crash was. Now this was something that was a mistake that I made. I said, hey, that should be this.track event. It shouldn't be just track event, right? So let me go ahead and add that. And I'm actually glad we also added Code Push, because guess what? Now that we have Code Push enabled, we do not have to go through the entire publish process again. We just can say, hey, this was a critical error. I made a mistake. I just want to change my JavaScript bundle. So I'm going to make a Code Push update, and there you go. If you now open your application on your mobile phone, the first time the app is loaded, it's going to see if there's a Code Push update. It says yes, it is, and I can go ahead and install this. If you notice, there was no requirement to do a native build. It was just a JavaScript bundle push, and life is good again. So there you go. I'm able to get my jokes as I wanted. Now that my analytics are also enabled, I can go ahead and look at what my analytics are. But before that, let me go ahead and close this crash, because guess what? I just fixed it, right? And in fact, the fun thing is I fixed it as if I was fixing bugs in a website, delivering it instantly to my customers. So here's the analytics panel, and the kind of information that I see here typically includes things like the devices that people use, what geolocation that they are in, etc. So that pretty much was what Mobile Center is for you. Now through this, I know that this demo was a little fast, and just to recap, let's look at the different technologies that we used in this demo. The first one was React Native for Windows. The reason we used React Native for Windows is because by default React Native supports iOS and Android, and if you want Windows platform, you would have to use this thing called the RNPM Windows plugin. The iOS and Android platforms are a part of the core React Native repository, while the Windows port is actually a part of the .NET Foundation. To get started, you'll have to npm install RNPM plugin Windows, and then just say React Native Windows and React Native Run Windows. And once you do this, your React Native Windows is just set up. The second thing that we looked at was using React XP. React XP was a thin cross-platform compatibility layer that lets you share your business or your view logic across all of these 4 platforms. This was created internally by the Skype team for their own use, and they've open sourced it. It's written in TypeScript, but you can also use it for JavaScript. The fact that it's written in TypeScript gives it excellent IntelliSense when you're using it with VS Code. The repository is available on GitHub at Microsoft/ReactXP. The third thing that we used was VS Code, and VS Code is an excellent editor for both React and React Native. VS Code has support for JSX, which is basically XML snippets inside your JavaScript code, and it also has amazing IntelliSense. The other thing is if you wanted to use VS Code for debugging, you can either use the VS Code Chrome extension to debug your websites, or the React Native Tools extension for debugging your React Native applications. The debugging experience is pretty much similar, so you wouldn't notice the difference if you are writing a web app or a mobile application. VS Code also supports a bunch of other community plugins or community tools like Exponent or Expo Player as it's called now. You can also launch it on your device, etc. And finally, we also looked at Visual Studio Mobile Center. Visual Studio Mobile Center is that tool that lets you do end-to-end DevOps for your mobile applications. Though we currently support iOS and Android, we are working on adding React Native Windows support. Mobile Center provides you lifecycle services like the ability to build, test, and distribute your application. It also provides you other services like crash reporting or analytics. It also has services for a mobile backend as a service, typically things like authentication, storage, identity, etc. Mobile Center supports React Native as a first-class citizen, and right now it's free to sign up. You should be able to head over to mobile.azure.com and sign up for Mobile Center. That's pretty much all I had to show you guys today. If you had any questions, I'd love to hear your feedback or questions. That's my Twitter handle and that's my email address. And that's pretty much all I had. Thank you.